This My name is Chandu. Uh, I'm doing the science one project one, and the question is I'm doing the first project one, and the question is the cat and rat problem. The square It's a square grid, and the given random walker is that the cat will be at the zero origin, and it is a 2D assignment, and the rat is at the n comma n, and the probability is we had to find the probability survival probability of the rat with the time, and there will be assume that there is the equal probability in all the four directions. So let the number of the steps along the x-axis be x, and the number of steps along y-axis be t minus x. The probability that it will be at the point n1 is n factorial by n10 minus 1 factorial and 10 factorial into 1 by 1.1 by 4 into n1 minus 1 by 1 4. Similarly, it is for the same for the y axis also. So the total probability will be the multiplication of the two problems, and we will get 1 by 4 into t into some x factorial t minus x 4 factorial by n1 factorial n2 factorial and x minus 1 n factorial and x minus 2 n factorial, and let x be the variable. So we find the total sum taking on the x, and then we can find the minimum and maximum for x. For x minimum is equal to n1 and y minimum is equal to n2. So x plus y is equal to t. So x maximum is equal to t minus y minimum, that is equal to t minus n2. Actual probability is equal to sigma t minus n2 is equal from x is equal to n1 into 1 by 4 per t into x factorial into t minus x factorial by x minus n factorial into t minus x minus n2 factorial into n2 factorial. As I meant for the boundary, like we have the boundary like this similar properties, right? Because the at the similar condition, like at the corner, and the probability will be, since the reflective mode, the probability will be changed moving from the x-axis and y-axis. So let's consider the probability at the points will be 1 by 2. So then doing the problems, like if the rest of the probability is equal to 1 by 4, and now this is the number of rows and columns. The number of rows and columns is equal to L by R, and n1 come to n2 has a range of 0 comma 0 to L by R to L by R. P of meat is equal to P of cat at the rate n1 comma n2, and the P problem that added the n1 comma n2, and the probability of n comma n comma t is equal to into probability of L1 L by R minus n1 into L by R minus L2. So the probability behind the probability will be in the form like this is solving, and the substitution from the above will from doing this step we have to submit the values in here, and we will get the probability like this, and we can finally say that it is the probability of n1 comma n2, it will be square. So what I'm saying is, as the number of steps as the number of the length of the grid increases, the survival probability of the the rat increases. Also, if the number of steps taken by the rat decreases, so the survival probability of the rat also increases. And this is the condition of the 2D. And while coming to the sphere, at any point of the surface, the probability of the theta with the z axis and alpha within the xyz plane. This is the 3D solving the problem. And the explanation is, fix theta with the given circles of points determined by alpha, and take the circle from the sphere as like the alpha, and we can find the right dt cos theta into d theta by sin theta, and read in that both the directions, that because it will be making axis theta and theta with this, so this will be r cos theta and this will be r sin theta. So probability of the making alpha is equal to d alpha by 2 pi. Since the angle is so small and the total angle will be 2 pi, the angle will be, probability is equal to d alpha by 2 pi. Area of the theta is equal to from theta to d theta by surface area r d theta into 2 pi r sin theta, because the angle made by the this is into is equal to r sin theta into 2 pi. So total r is into 2 pi r sin theta into r into dr by 4 pi r square, the total surface area. P of theta is equal to sin theta by 2 d theta. P of theta by alpha is equal to sin theta into d theta by into d alpha by 4 pi. After displacement d, let the alpha comma theta change into alpha nu comma theta nu. We can take the A comma B as reference lines, and A is the longitudinal angle with the xy plane is alpha, and added angle is z axis is theta. D theta is equal to arc length by radius, d cos pi is by r, and theta nu is equal to d cos pi by r. It would also be because the theta, we know that, right? Because if the length changes, the theta and alpha changes with the similar directions, so it would be like also be d theta plus r by depends on the movement. D alpha is equal to d sin theta, d sin b by r sin theta. Alpha nu is equal to alpha plus c sin b by r sin theta. Then could be a minus also, like it can move in the both directions, right? So we can consider the both directions. Assuming assuming the direction is so small, the displacement, rat and cat will cover that complete surface of sphere. Probability density of function will be w of theta comma alpha into d theta into d alpha. For to calculate it, p of theta comma alpha sin theta d theta by d alpha by 4 pi. We found it here, and sin theta by d theta is equal to d sin beta by r sin theta and d cos beta. The each we found here, and now integration from probability of we have to integrate from complete alpha and complete data. Omega of theta comma alpha square and theta and d alpha is equal to, we have to integrate from 0 to 2 pi and 0 to 2 pi. So we are saying d power 4 by 8 r power 4 sin square by cos square b. And can we have to find the limiting value of the survival probability when the step length is infinitely small or the number of steps is very large. So if the number of if the step length is infinitely small, then it is directly proportional to 1 minus 1 by L power 4, and L power 4 because it is d by r power 4, d by r power 4, it is infinite, it is inversely proportional to 1 by r power 4, 1 minus 1 by 4, so it is directly proportional to r power 4. You can say it like that. And also, as the step length increase, as the radius increases, as the number of steps increases, is sufficient large, the probability also of cat finding the rat also increases. So this is the limiting case.